Hello and welcome to the Dropping In Surf Show. My name is Rob Case, and I am a surf paddling technique coach located in Northern California. This podcast is all about math and science in the world of surfing, or at least we try to relate it to the world of surfing. And today's episode has a lot of math in it, so I'm already apologizing ahead of time for those of you that are math phobic, but I wanted to talk about how social media and surf forecasting are alike. And how are they alike? They're alike because of algorithms. So what is an algorithm? Well, an algorithm, as if you're watching this on the screen, we have the definition. I'll go ahead and read it to you for those of you guys that are driving around. An algorithm is a finite set of instructions carried out in a specific order to perform a particular task. It's not the entire program or code. It's just the logic to a problem represented as an informal description in the form of a flowchart or a pseudocode. So maybe let's talk about how algorithms work. All right. So essentially what we have is there is some sort of input. They take in just data sets. And the algorithm then goes through a set of rules or tasks to execute a certain output out the other end. And the output is that result, a decision, a result, a strategy, or some sort of meaningful information. So these are the key aspects to algorithms and using algorithms. You have input, you have an output, and the algorithm's in the middle converting that data input into something meaningful out the other end. There's some other aspects of algorithms that are important to understand, one of which is efficiency. So, how do they accomplish these tasks as quickly and with as few resources as possible? That is something that they measure. So you can have an algorithm that is extremely inefficient, where it uses enormous amounts of resources, meaning storage and memory processing, to get an output. And the output could be good or bad. It's just a matter of the efficiency. That's what they're measuring there in that aspect. And then there's that other side of it, is how good is the output? What is the optimization of it? The optimization could also mean that it could be faster, but it also could mean that it could be more reliable or more accurate of an output based on the inputs that are being put in. So, there are numerous uses of algorithms in our natural world right now, natural and in natural world. There's data analysis, and machine learning, I think, is the number one big thing that we're seeing right now. They're taking huge data sets and they're converting them into something meaningful. But really what they're doing is they're converting them into forecast outcomes. Sound familiar? So machine learning methods are actually helping to learn from past mistakes of the past algorithms at making them more efficient, making them more optimized, and making the output improve over time. So not only are there algorithms out there that were manually created, but now there are algorithms on top of algorithms with machine learning, so that the computer does the faster work at optimizing and making these algorithms more efficient and effective. We also have algorithms in cryptography, security, search engines. Why do I get the same search engines every time when I put in certain keywords? Different optimization problems in business and in industry, medical diagnostics. They're using algorithms, so they can use algorithms in many different areas. Some specific more characteristics before we get into relating this to social media and surf that we need to know is that there are certain characteristics an algorithm has. to solve that task or solve that problem that has been posed to it. And they include things like finiteness. So every algorithm must have a finite number of steps before it ends. If it doesn't, if it's infinite, it'll just be this infinite, endless loop that will never actually spit out an output. And I know this from personal experience when I took a computer science class as an undergraduate, and my computer kept crashing because I didn't, it always ended up in an endless loop. So hence why I studied general mathematics, essentially mathematic theory, rather than computer science. An algorithm also needs exact definitions for each step. Clear and straightforward definitions ensure that every step is understood and it can be taken easily. So definiteness, so finiteness, definiteness, definiteness. I don't know how to say that, but it needs to be defined. And then input, obviously, an algorithm needs and it requires inputs, and the more inputs they have, the larger the algorithm becomes, but the more accurate the output could be. The inputs actually need to come in as acceptable values in a predetermined range. So thinking about how algorithms might be used in surf forecasting, if the data in is bad, the data out is going to be bad. Or asking yourselves, what is the quality of the data that's being put into these algorithms? And that should help you determine how much weight you put on the output. Obviously, there's the output itself. It's the outcome. The relationship between the input and the result really should be clear. You put in certain inputs and the output should relate back to those inputs somehow. It shouldn't be that, I'm wearing a red shirt today and therefore the surf is going to be 4 to 6 foot. There's no correlation between those two. So there should be a bit of relationship between the output and the input that's pretty clear. Effectiveness, we kind of talked a little bit about that. And then generality of an algorithm. So, an algorithm can be designed to be a particular singular case, but making algorithms a little bit more general can then be applied to multiple problems. So that's kind of where we get to, in terms of a problem can actually have several solutions to it. And when we look into kind of the quality of an algorithm or the quality of some sort of series of algorithms, it's how quickly, you can have 4 solutions to the same problem, but which one is the most eloquent, efficient, optimized, accurate, would be something that we're always trying to kind of improve with an algorithm. And there's lots of different types of algorithms. I'll just go through a couple of them. There's this thing called the brute force algorithm. There's recursive, there's encryption, there's backtracking, there's searching algorithms, which is like search terms on Google, sorting, hashing, divide and conquer, greedy algorithm, which I think is a fun name. And we don't need to know what these are, but there's just lots of different types of algorithms or themes of algorithms. But at the end of the day, what we're trying to figure out is what is a good algorithm from a bad algorithm. So you have this problem, it has multiple solutions. What makes a algorithm good or bad? Well, efficiency and correctness. Efficiency, we talked about that. Using minimal resources. Correctness, it must produce correct and accurate output for all the valid inputs. Clarity, it should be easy to understand. Scalability, as it gets larger and larger data sets and problem sizes, it shouldn't decrease in performance. So if you look at maybe the history of surf forecasting in some of these sites like Surfline, the data sets were kind of small in the beginning when it was like 976 surf. You'd call up or you'd get a fax. And the data sets for those were pretty low. As they went online and they started building algorithms now, was it scalable? And at times there was almost too much data coming in, and so the output wasn't very good. The performance actually went down. I think they've solved that in the last decade and a half to a certain extent. But now they're about to get even larger data sets. So the question is, are they ready for it? And I'll address that a little bit later in the episode. Another quality of good algorithm is reliability. Is it delivering correct results under different conditions and environments, different variables that are coming through, things that are changing. Optimality, that's what we talked about. Are the results optimal given the amount of resources? Robustness, can it handle unexpected inputs or errors without crashing? If there's a typhoon or there's a tsunami in the input, will it crash, or can it deal with those unexpected occurrences? Adaptability, can it be applied to a range of related problems? I guess in surf forecasting, it's not, there's a certain amount of problems that we're looking to answer, and then can it be simple? So those are all qualities of good algorithms. But there are some complexities that we need to understand when we're looking. I'm going through this so that you guys understand the output of some of these surf forecasts, and you appreciate the output that they provide us through all these algorithms that they're running. And so there's two major complexities of algorithms that are outlined. Really, time. How long does it take to execute an algorithm from start to finish, which is the process steps? It's the number of steps required to complete the execution, and it's the speed of each individual step as well. So that can vary. If you have something that just takes a while, like a lot of my programs when I was trying to learn code, it took a long time. They were very inefficient. And if we were waiting for an output, that's just a human behavior to be impatient. But at the same time, there are needs for things to be a lot faster in general, so that we're not just waiting around, but in order to get to maybe the next step and then the next step after that. Now, while things take longer, they're also processing more on a physical hardware point of view, and that is a strain on the system as well. So there's complexities around time. And then space, which relates to kind of the hardware issue, is that, how much space does it need in terms of storage to solve a problem? I had people in my classes that, could complete our assignment in, say, 200 lines of code, whereas mine was like 1,500 lines of code. So not only was mine longer to execute, but it was really clunky, took more space on the computer. And so there's not only the space of the algorithm itself, the auxiliary space, but there's the input space, all those data sets. So if we take my program versus somebody else's program, if we increase the data size, mine would by far struggle a lot faster than my classmates, who coincidentally, not so coincidentally, went on to study computer science, whereas I deviated to another track. So those are the complexities. I think we've already kind of covered some of the advantages and disadvantages of algorithms. Problem solving, scalability, automation. We actually haven't really talked much about automation, but I think that's a given. Automation is a huge advantage of having algorithms. This was, 976 Surf was handled by a handful of people that would put on a recording, so it was semi-automated, but I don't know what kind of algorithms they were using, if they were using any at all. They were just taking a look at the inputs, the data inputs, and then converting it into a message out to us that called into the line or asked for the fax report. So automation is a huge one. Disadvantages, Yeah, let's go through disadvantages because this is really important to understand. Obviously, the complexity of it, sophisticated algorithms can be really challenging, time-consuming. Limitations in terms of you might not have efficient algorithms because the data inputs have not been consistently there. So when I look at, again, the surf forecasting history, early on there was data input, but when we go into the details in a moment here, some of the detail input, it still actually isn't great data that they're using. Now, over time, they've been able to modify their algorithms and really be flexible with them and change them and use past observations and past data to come up with solutions to some of the problems. And so they've done a great job at evolving these limitations of input data. And now they've come up with a solution to increase that even more. So other disadvantages, resource intensive, we talked about. Inaccuracy, we just talked about that. Maintenance, keeping these things update, relevant, and effective is a lot of time and work. And that's part of what you pay for when you ask for one of these services is we need to understand, how much work is actually going in this. This isn't one of those things where they build one algorithm and then they cash in off of a single program. They're constantly trying to test different variables to make it more accurate, and that's a wonderful thing. They're trying to get better. So some examples, some simple algorithms, guys, in our lives. I've just thrown up on the screen just some simple images. Tying our shoes. It's a simple process. There's a limited number of steps. And guess what? The solution can come different ways. We can use the bunny rabbit approach or loop, swoop, and pull or through the hole. There's lots of different techniques of getting to the solution. Those are all different algorithms that we have used in our life. Following a recipe, same deal. You could end up with the same result, maybe a slightly different outcome in terms of taste or texture, but there's a bit of artistry in the algorithm. Which one is more efficient, uses less resources, but ends up having a similar outcome, right? So, and then the last example that I have here is actually just driving to or from somewhere. Driving. And there's additional complexities that may arise during the processing of an algorithm or the processing of the steps that lead to the tasks that lead to the end result, right? Like traffic, right? Traffic, construction, which may create like an if-then choice within the algorithm. Should I stay on the street? Should I go to the highway? Should I turn left or right? Should I take a different route? Now with GPS, we have a lot of that does that for us. But even our decision on should we listen to it or not is really important. I always have this constant battle in my car, in my family car, when the program reroutes us due to traffic, say going from LA. If it's a long trip, I usually stay the course. And my mindset is that if everybody's using that same program, everybody's trying to now spin off to the alternative route. Now the alternative route is bottlenecked, and the main route will eventually clear up, whether it's a construction or it's an accident. And so I kind of zag when everyone else zigs. It's very similar to how I am in the surf as well. But these are just simple algorithms in our life. But the driving one and the example with how complexities arise and the kind of predictive element of driving, it leads us to predictive algorithms and predictive analysis. So what are these things? So predictive algorithm is a set of mathematical equations and statistical techniques used to predict an outcome or future behavior based on historical data. So a lot of people will think, isn't that just a normal algorithm? No, a normal algorithm is a series of steps. A predictive algorithm is the same as a series of steps, but it's to achieve a prediction of a future outcome. So it's a slight difference between the two. So predictive analytics is the use of data to predict future trends and events. It uses historical data to forecast potential scenarios that can help drive strategic decisions. It can be conducted manually, or it can be used, using machine learning algorithms. Predictive analysis can be conducted using machines and algorithms, essentially. So either way, historical data, it's used to make the assumptions about the future. So think of an algorithm as a series of different variables and steps and tasks. Now, predictive algorithm and predictive analytics is now taking all of those input data and trying to determine which ones drive the future, or a predictive future, or a higher probability of what's going to happen in, say, a day, 2 days, 3 days, 4 days, 7-day forecast, surf forecast, right? So examples, in your own life, you do this, right? You leave for work early based on rush hour traffic you've encountered in the past, right? Over the years, or over the month, or which day of the week. That's predictive and analytics, and you're doing it yourselves. Our brains are amazing computers. There's financial forecasting, predict the price of commodities moving forward. My past life, I used a lot of this, actually. Did a lot of regression analysis. Marketing, behavioral targeting. Sound familiar with social media? Examining historical behavioral data can predict a lead's likelihood of moving down the funnel from awareness to purchasing, right? Social media, you have historically scrolled through baby animal videos and will continue to push those to your feed because of the historical data. And then, of course, with surf forecasting, you've got historical data with buoys and wind and barometric pressure and water temp and wave size and tides. And they all contribute to a surf forecaster's predictive modeling for future waves, their predictive algorithms. So these are all the inputs, or the historical data that's put in. So simply put, predictive analytics is predicting future events and behavior using older data, which also means it can be wrong, right? And we're not entirely sure which data inputs are directly correlated. And so that's a part of the testing that you're constantly doing when you're doing these kinds of models. When you add even more complexity, predictive analytics starts to meet artificial intelligence and machine learning through the testing of all these new variables to the algorithm. So, for example, in the baby animals video, a testing algorithm may send you an animals attack video to see if you bite. Pun not intended there. But if you do bite on the animals attack video, then that becomes a part of your social media algorithm. And they may be adding more and more into the entire equation, to the entire algorithm. If not, if you don't bite on it, then they may attempt different videos, like something similar to baby animals, maybe like animal interactions with humans, and see if you bite there. So in other words, something that's related to what your historical behavior pattern has shown, and they may also test popular variables that are really kind of unrelated to your historical behavior from time to time. So for example, you may from time to time get a fails video, because fails videos are very popular. And if you bite and watch that, then maybe they'll send some more, right? And so those are more based off trends and popularity, just to kind of test what those algorithms are doing, what the AI and the machine learning is doing, is it's learning how easily do you bite on these kind of like impulse kind of videos, and what are your interests, right? So testing new variables, it's important on a constant basis to find new patterns and develop new predictive algorithms. But also, it's good to test the changing input data, because the input data is not always the same every year. So for like surf forecasting, or let's say weather patterns, a good example, weather patterns around the world, they've kind of changed. If you look at, say, short term versus couple years worth of data versus decades of data versus 50 years of data versus 100 years of data. So when you look at, say, a longer period, there might be a broader pattern. If you look at like a shorter period, there may be a different pattern. How did those patterns change? How did those inputs change over the course of time? So as these macro and micro patterns change, testing new variables into the predictive algorithm is important to make sure there isn't a new pattern emerging, which can then be used for a modification of the original algorithm, or just to add to the existing algorithm data set. So, question: how is all this like surf forecasting? I've kind of alluded a little bit, but it all works. It all works the same, but we have far fewer input data than social media. But it is getting better, as I'll explain. With something new that's coming out. So if we go to my local kind of Surfline page, the historical data that these algorithms have been using, it's consisted of buoy averages. So if we look at, say, these inputs here, these are the buoys, the buoy report. This is actually the algorithm. This line, I'm looking at the swell lines, the swell forecast. So these are the algorithms that are actually coming out. So these are the results, in fact, of the input data from historical buoys and their predictive algorithm for this location. And so what goes into this output algorithm? Well, one of the things that I know goes into it are the buoy readings for the surrounding buoys, offshore buoys. So what are the offshore buoys? I think this is probably the best map. I'm at cdip.ucsd.edu, and it shows a global map of the CDIP buoy readings, the buoy stations. And so I'm zooming in on the San Francisco Bay Area because that's where I'm at. And the San Francisco bar buoy is right there. So I'll click on the bar buoy and ask for the data. I know that this data, in a variety of different ways, is going into this Central Ocean Beach forecast, that the swell line forecast. This algorithm output is being fed by buoy data. I know that that's not the only data that's being put in there. I know that these actuals are not the only thing. The history that they've captured over the years on this same day at the same time frame, or the same swell direction, the same tide. I know that they have algorithm and inputs of all that. They have a lot of history at Surfline. But you can see at CDIP, they have their own forecast. Well, I'm sure their forecast isn't quite the same. I'm sure they're not using the same forecast, but you can see here I'm showing the CDIP San Francisco bar conditions and forecast, and there's a blue kind of dotted line, which is the actual pings of the buoy, and there's a red line, which is the forecast. And you can kind of see that it generally moves similarly, but it's off by a bit. I think one of the most clear things was the direction change. The predominant direction was delayed by a few hours before it went south, and it didn't go as south as it was predicted. You had a couple pings. The other thing this shows is that these are individual buoy pings. They're averages. So the buoy goes up and down. This one, I think, reports every hour or so. Well, there's a lot of different waves out there in the water, and actually when you go back to Surfline and you go down to view buoy data, you can see all the different inputs that this CDIP buoy is pulling. If we go into this 9-band direction data and height and plot, we'll get all those different ones. But essentially, if you went into Surfline and kind of scrolled down, you can see all the different types of buoys and swells that are coming in. There's a 280 degree, 8-second swell. There's 230, 17-second swell. There's a 215 degree, 13-second swell. There's a 280, 5-second swell. There's 255, 4-second swell. And this is every half hour. Every half hour, this is pinging. Now, these are averages, right? These are, it could miss a ping. It could miss like a major set that comes through. So the idea is that we get enough, it's pretty infrequent. It's every 30 minutes. It's not every minute. It's not every 30 seconds. It's not every 20 seconds. It's not every 10 seconds. So there's issues with data input that get put into the resulting Surfline forecast algorithm or predictive algorithm, right? So there's buoy data. And that's dominant, secondary, tertiary swells, direction, height, frequency, period. Frequency period is about the same. There's wind. They do water temperature. I'm sure they do air pressure. When you look at their charts, where's their charts? If you go to their charts and you look at the Surfline charts and the swells around the world, they're looking at a lot of different things, not just this buoy data. They're looking at barometric pressures around the world, wind data from anemometers, which are wind measuring devices. They're looking at pressure data from barometers, and they're looking at other weather algorithms in general, capturing storm data like fetch and direction. If this thing ever comes up, it's still processing. And really, I think the last thing they're also capturing is first-party observations on various beaches around the world, right? And so that's where I think we run into these issues that much of the information are averages, just due to the amount of information that's out there in the ocean. And the remoteness of it. They don't have buoys every 2 feet. The buoys are spread out if they are even in your area at all, right? So that's another problem. The pinging of the buoys, if you do have buoys, the pinging of the buoys, it changes all the time too. How often? Is it every 30 minutes? Is it every hour? Is it every day? I do know that they're a good example of this buoy. One of the big swell events knocked the buoy out of operation because it was just so big. It actually knocked the buoy out, and their algorithm was off. Once the buoy came back on, like a week or two later, their forecasting algorithm was off quite a bit. So I do know that they used that buoy's information, and it's a large variable or parameter for that historic data. It's not the only one. They were still able to get a predictive forecast out to us, but it was definitely off. And so I'll explain how I know that it was off in a bit. But anyway, the real-time data that they are receiving are still averages, and that's another problem. And then similar to predictive weather forecasting, surf forecasting uses, particular variables that have their own historical patterns. So there's seasonality, regionally, globally, different patterns. So in areas where there are no buoys, they're using more historical patterns and weather-producing algorithms to predict swell, and then they're combining that with human observations over the years and decades that they've been in operation to say, oh, well, this angled swell at this period and this size, and it being the only swell in the water, produces this kind of conditions given this tide and this wind. And those, you don't know that unless you're on every coastline in the whole world at every moment of the day and night. So why isn't Surfline and other forecasting sites, accurate or correct all the time? Well, I think we've covered it. It's the data is just not robust enough, right? You don't have, it's pretty good, especially from when they first started. And it's gotten better each year because they're constantly they're challenging their algorithms, they're putting new inputs, they're testing new things. But it really pales in comparison to the amount of good data coming in for something like social media. So they both use algorithms, but the effectiveness and efficiency of social media algorithms are far, far superior. And part of it has to do with the amount of input, and the quality of the input. So it's kind of like bad data in is going to produce bad data out. And if you have more and more and more data, you have more things that you can test and adjust your algorithms to make it correct. But the amount of data is only one problem with surf forecasts. The quality of the data is another. Most of the inputs are averages, which we talked about. They're not super granular in frequency to provide good output data. And I think they know that, and they've been trying to get better. A good example of this is, when you go to your report forecast, at least in Surfline, they have this question that always pops up. Some reason there it is. And that question is, was our forecast accurate last time you surfed here? Yes or no? Here it is. So they know that they need more input. They need, observations. They need additional observations. What they're trying to do is they're trying to get that additional data points to fine tune their algorithms for that particular location, because now they have so many locations. It used to be they'd only had a handful of locations, and they'd cross-check with people that were on the ground, and that's how they started to get better. Now they have so many, and so for any given location, they have so many different algorithms working, different patterns to test and see if the output is accurate or not, or how close does it come. And so they're asking for our help as additional data points. The problem has been that surf forecasting sites, when testing quote unquote reliability of their algorithms, they've been using humans and their opinions to determine accuracy. And when was the last time that you asked two surfers to tell you the size and conditions at the same location at the same time of day, and you got the same answer from both of them? I'd put money down that the reports were similar, but still different, right? Because all humans, we view things differently, right? We're not objective in our analyses. There is so much subjectiveness in how we view something. Oh, it's 5 foot. No, it's 2 foot. It's fun. Well, what does fun mean to you? Does that mean lots of waves? Does it mean that the waves are, there aren't a lot of them, but they're long and clean? There's just too much unknown, even when you ask the same human to report conditions on a daily basis at the same time of day at the same location. So even their mood might dictate a different answer from the day before, right? So that's why I've always cross-checked the forecast, this line forecast where it's showing me, let's see here, tomorrow that there's going to be a wind swell 4.6 at 8 seconds, that there's a south swell 1.6 at 15 seconds from the southwest, from 197. There's another one, 1.1 at 12 seconds. And then there's this longer period south that's underneath all of it. I always cross-check this with the buoy readings and the CDIP buoy readings that come through as they come in. And I check to see, okay, historically, what has their algorithm spit out and what has actually pinged the buoys. Is it larger? Is it smaller in size? Is it from a different direction in size? I'm lucky because we have 2 buoys here. We have, if we go back to this map, this CDIP map, there's actually 2 buoys. There's an offshore buoy, an outer San Francisco buoy, and then there's the inner San Francisco bar buoy. And the San Francisco bar buoy is in like 50 feet of water, and the outer bar is something else. This one's Point Reyes. But there's another outer bar out here. There's another bar buoy out there, or not the bar. It's the outer buoy. And so what I can do is I can look at the outer buoy, and I can see this one's 18 nautical miles west of San Francisco, and I can see what swells are hitting that so far out in the ocean, and how does it refract into the San Francisco bar buoy, and how does the direction change? The same swell, how does the direction change? And is it going to maybe curve into the beach that I'm most interested in? Maybe not this beach, right? So that's how I've traditionally and historically cross-checked the surf forecast. And I'm not looking at their interpretation of the surf forecast. I'm not looking at 2 to 3 foot plus in Port-a-Fair. I'm looking at my own. I'm converting these swell forecasts into my own interpretation of what I might see at the beach. If you write it down on a log, I used to do this when I was younger. I used to write it down on a calendar. I used to call the Surfline report or call the local surf shop report, and I'd write down their report, and then I'd go to the beach and I'd write down at that particular beach how fun it was or how big it was, that sort of thing. And that really helped me along the way. So if you do a personal log, that's a fantastic way of doing it too. That's your own personal data input. At least you know your own biases and preferences as well. But I will say that Surfline has a promising new future. One that's providing them with more and higher quality objective data points. Have you seen their new Premium Plus features? The Smart Cam Insights specifically. I know this is not an advertisement for them, but I can see that they're trying to solve the human reporting problem. Right? They are doing their best at trying to solve this. So they're using camera technology, and so they're using camera technology to determine a couple things. To track, they may be tracking more variables, but they're using cameras to track wave size, number of waves surfed, frequency of waves in a given amount of time, and crowd, which I think is those are awesome. So it's total number of waves, the number of surfed waves. They're also doing size on the app. I can't find it on this desktop version, but they're doing kind of size. You can click on a wave by wave by wave, and you can actually look that 5-foot wave. Again, they have their own defined size measurement benchmark, right? And there you can select one and say that one was ridden, that one was not ridden, that one was ridden, that one was not ridden. And the camera algorithm, it has its own certain parameters to set or that are set to determine this size across all different locations. They have a metric to see if a surfer is actually riding a wave versus not riding a wave. And as it collects this data, they also get that frequency of waves per unit of time, and they can count the number of bodies bobbing around in that frame for the observed versus predicted. So I wonder if I go in here and look at this singular one, maybe that's where it's going to show me. There it is. So if I look at the Smart Cam now, you can see here that this was a wave that came through a little bit over 2-3 foot, but it was not ridden. This one was ridden, and this one came in about 4 foot range, and it was ridden. And the camera's reading someone riding these waves, which is fascinating, right? This one was a big set 6-foot wave, and again, this was ridden by somebody. So yeah, could you call that more like a 3-foot wave? Sure. But they have their own parameter. They have their own metric. From this, their predictive algorithm for this site at this location will get better. It will get better immensely. combining this with their historical algorithms and current input data for a particular location, they'll be able to further refine these forecasts without human biases getting in the way, because these are objective, right? They've at least noted these. And I'm sure that they'll continue to add more parameters to collect data on. The wave condition, is it clean? Maybe the length of ride they might do. I can see that. Number of maneuvers on a wave. I can see them doing that. Maybe they're already looking at all this and they're just not reporting on it, right? But I sure hope that they are collecting those things, because those are objective. Those are things that can improve their algorithm for that particular location. And I'm really looking forward to seeing the forecast that these spots get better and better. Does this take the romance out of it? Yeah, a little bit. The romance of rolling up to the beach when the forecast says Port Affair, and then having the session of your life. Port Affair is like my go-to. I love Port Affair. Yeah, it kind of does, and it probably will take a bit of the romance out of it. But so far, the input data, it's only for those spots with the Premium Plus camera or algorithm installed. So we're still safe at spots without cameras to continue to feel that kind of what if nervousness we feel when we think we can predict the surf using an old weather radio and the aches in our joints. We're still safe. I think we're okay for a while on some of those other areas. But yeah, I think that I'm excited to see how this math and this science gets incorporated in our daily lives. I'm really, really excited to see them move into this next stage of advancement in machine learning. But yeah, we'll still have our chances to go old school and have that element of surprise at all the places that they don't have cameras up at, and they're not tracking algorithms at. So hopefully you learned something about algorithms. Hopefully you got kind of excited about algorithms, or you got more scared of algorithms. Either way, until next time, I'll see you in the water.